Hi everyone. Okay, good morning and welcome to part 2 of math today. It is going to take a little bit of a step up today because we're learning about 2 other types of transformations. Now, do you know what the 2 other types of transformations are? I can hear some of you saying that we know that yesterday we learned about translations, right? Translation is a slide. Today we are learning about what's the other one? It's called I should put my hand this way, like this, right? It's called a reflection, or AKA a flip. And then we're also learning about this. What is that? That is called a rotation, AKA a slide. Okay, so we're gonna be doing those today. All right, here we go. All right, so again, we're on with the same I can statement, okay? So we're describing these different types of single transformations, performing and describing them. So the 3 types, we did 1 yesterday. The next one, number 2, is a reflection. Okay, so AKA, it's a flip of the shape, okay? The next thing that we need to be able to do, or next thing that we have to identify about a reflection is something that's called the line of reflection, okay? Basically, it's like if you had a mirror that you were putting between the shape and the image, where would that line of reflection be? Sometimes it's touching the shape, okay, like right touching up against it. Sometimes it's a couple of units away. So we have to be able to identify that. There could be a question where they just give you a reflection, they say, describe the line of reflection. What is the line of reflection? Or where is it? Okay. All right. Okay. Also for reflection, right? The 2 images, or the two shapes. So the shape and then I guess its image must be congruent. Okay. That's the same with all of the transformations that we're doing. We don't have any like expansions or contractions. Nothing's blowing up or nothing's shrunk down. Okay. All right, now this is how we describe them, which is part of our I can statement. How do we describe the reflection? So we have to say a couple of things, okay? So the first thing we need to identify is the position of the line of reflection, okay? So you'd need to say whether it is vertical, if it's running vertically, or if it's running horizontally, or if the line of reflection happens to be on a diagonal, okay? And we could get any of those. And in this case, this one is, we would say this is a vertical line of reflection, okay? All right, now the other thing that we have to do is, another thing, we're gonna practice another one of these in a second, but we might need to also identify where this vertical line of reflection sits. So like if we had a coordinate grid, right, like a Cartesian plane, where does this fall? Maybe it's on x equals 5. Maybe that's where this line goes. It goes up the 5, for example. I'll show another one of those in our next slide. Okay, the next thing is we have to figure out how far this shape is from the line of reflection. And the thing is, it must be an equal distance away. So in this case, we would probably say B is 1 unit away from the line of reflection. Maybe it's further. Maybe it would be 2 units away. Maybe it's touching. Maybe it's 0 units away. Okay, but the key thing is, especially if we're determining the line of reflection, we have to be able to know that the line of reflection has to be symmetrically placed between the 2, the shape and then its image. Okay, so here is just an example. So describe the reflection. So we would say B has reflected around the vertical line of reflection, okay? We're gonna do another one right away. So you could draw that down if you could draw this if you wanted to, but we're gonna do another one that's a bit more complicated. Okay, so here is a better one because this actually shows like an image and it's, or I guess it shows the shape and then its image in the line of reflection. So we know that what is the image and then what is the original. Now we learned this yesterday, right? When it has the prime, that shows that it is the image. So we know that this was the original shape, and then this one is the image. Sometimes they'll show it with a different color, but the more like technical way to show this is with these like little hashes that say it means it's prime. Okay, so again, we describe by saying the position of the line of reflection. Okay, so let's describe that. So what is this line of reflection? It is a vertical line of reflection on the x equals 5. So it's a vertical line at x equals 5. I'll write this down. Vertical or horizontal. Yeah, okay, then we have to figure out how far away this shape is from the line of reflection. Okay, so here's our example. Describe the reflection. Okay, so I'm just gonna write this down. All right, so we have a vertical. You're so much faster at printing this than I am with this mouse deal. Vertical, okay, line of reflection at, I'm going to say it's at x equals, right, because here the horizontal axis is the x-axis, so it falls at x equals 5. Okay, so it's a vertical line at x equals 5. Okay, hopefully that makes sense. We might think, well, it's going up and down, so that's the y-axis. No, if it was a horizontal line of reflection and the line of reflection was here, for example, then we'd say it's a horizontal line of reflection at point, because this is the y-axis, right? It'd be at point y equals 9, okay? And then we know that it has flipped, well, we would say it has flipped 1 unit away. Okay, so we look at the L, we look at the closest point to the line of reflection, which is in this case the L. It is 1 point away, right? So how far is it from the, we would say 1 unit. Looks like a 7 or something. 1 unit. Okay, 1 unit away, or away, yeah, away from the line of reflection, okay? Yeah, there we go. Okay, alrighty. Next thing that we're doing is rotation. Okay, so this is the third and final type of transformation, which is called a rotation, aka a turn, okay? So the first thing we must do is we must identify the point of rotation. All right, this is more challenging. I'm not gonna really show it with this like little example here. I have a better one to show, which is actually on a Cartesian plane on the next slide. So we'll just write down these notes for now though. So rotation, aka a turn of the shape, we must identify the point of rotation. So for example, the point we'd say is like, the point of rotation is like bracket 5, 5,7, if that's where the little point of rotation is. I'll show you on the next one though. Then, oh yeah, okay, of course, same thing, blah, blah, blah. We have to have the two shapes must be congruent. They must be identical twins. Okay, so then we describe the rotation by saying the direction of the rotation, okay? Super important. Did it turn, this was like on your title page yesterday, did it turn clockwise or did it turn counterclockwise? We might also say to the right or to the left, okay? Yeah, those are the two most common ways to say. It might be like east or west, but it's not super common for this. Okay, then the other part is we have to say the amount that it rotated. So how much? This was also on your title page from yesterday. Did it rotate 90 degrees? Did it rotate, which is, you know, like a quarter turn? Did it rotate 180 degrees, which would be half a turn? Did it rotate 3/4, which would be like, what is that, 270. So, okay, so here we go. I suggest that you write this down. This is kind of like a little cheat sheet, okay? So the amount, did it rotate 90 degrees or a quarter? Okay, that would be this one. This one rotated a quarter clockwise, we would say, because it even like the arrow even shows us, okay? The next one would be, okay, or 180 degrees, which would be a half turn, or 270 degrees, which would be 3/4 of a turn. Now, I know you're probably thinking, oh, we could have a different turn. We could have maybe like a third of a turn. We could have maybe like, we could have a 1/6 of a turn. Yeah, you could, but honestly, in grade 6, these are the only ones that we're gonna be given. Okay, a little bit easier. Yeah, okay. And then, oh right, then you might also need to identify the point of reflection, which is where you'd have to say the ordered pair on the grid, okay? So no, this was a little bit of writing today. You probably had to pause me along the way to get all of this down, but this stuff is really important to be able to have when we are accurately describing. And I guess also because in the reverse way, when you're performing or you're actually conducting these transformations, then they're gonna give you this set of instructions. So you need to be able to know what each of this kind of thing is. Okay, here's a better example. So we're going to describe by saying the direction, the amount of the rotation, and then we're going to say the point of reflection. Okay, so here we go. Alrighty. Okay, so first of all, direction. Which direction has this turned? Well, I'm looking at my arrow and it tells me it has turned clockwise. Okay, so clockwise. If we were in class, I would have printed this little guy out for you. Okay, so clockwise. Okay, clockwise. Amount. How much of a turn is this? So if you think of, so the best kind of way to do this is you pick one of the branches like this, okay? And then you find the other congruent arm or congruent branch to it, okay? So I'm looking at RS and then I found RS prime here, okay? So how much has that turned? Well, if it only went to here, right? That would be 90 degrees, right? We see this would be 90 degrees, okay? Not a 90 degree. If it went here, right? This would be 180 degrees. Is it 180? No, it's gone again. It's gone again 3/4. 1/4, 2/4, 3/4, okay? So it's a 3/4 rotation. Whoopsies. 3/4 rotation, or it's good to put in both because you never know, you could be given it in degrees or you could be given it as a fraction form. 270 degree. Okay, so I get in the habit of writing down both of them from the little cheat sheet on the page before. Then we must say the point of rotation. Okay, so our point of rotation is this R right here. Okay, so I need to identify what the point of rotation is. So it rotated, I can say like rotation or around, it might say like around rotation point. Always we say the ordered pair, right, in brackets. So R is at 6,7. 6,7. And I'd have to call it R, okay? So it's over point R, which is 6,7. Okay? Alrighty. Okay, cool. All right, good stuff, guys. Okay, so hopefully that kind of makes a bit of sense. Today, you're going to be practicing performing them in your homework and also describing, okay? Now, this is sometimes this requires a little bit of like brain gymnastics, and I really, you people that like to use pens, for drawing, okay, for drawing the initial Cartesian plane and drawing the initial shape, you could use a pen, but you got to be pretty exact because sometimes you're like, I didn't actually draw that correctly. But then when you're doing these rotations and flips and translations, you need to use a pencil, okay? Because you could possibly do it wrong and then it takes quite a bit of practice to get it right. Okay, so this is the homework. All right, so page 298, 299, questions 1 to 4, which are due tomorrow, okay? So, okay, here we go. So here's number 1. So you have to copy this onto our Cartesian plane. So this is like surgery, to be pretty exact. So the 7 falls at F falls at 7,6. So I suggest you draw the vertices first and then you connect the dots, okay? Then what you need to do is, it says here you have to perform a translation. Okay, so pick one of the points and then it's going to go 6 left, 1, 2, 3, 4, 5, 6, and then 1 down. Then you plunk in the F. Then do the next thing for D. 1, 2, 3, 4, 5, 6, 1. Plunk in the D. Then E. 1, 2, 3, 4, 5, 6, 1. Plunk in the E. Okay? Then label it D prime, E prime, F prime, and then connect. Okay? Then you have to write the coordinates of the new vertices. And then you have to add another point on the grid. Okay, and then do the same type of rotation. What's going to happen? Okay, yeah, cool. The next one is this one. Okay, so this one is way trickier. This is going to require definitely some mental gymnastics. copy this, and then you have to perform, I think, the reflection. Fun times. And then this one is more just describing. Okay, so you have to identify what has happened. So from the shape, which is right here, to image A. How did the shape get to image A? What has happened? How did it get there? Okay, was it a rotation? So was it a reflection, a rotation, or a translation? Okay, I'm gonna give you a hint. There's one of each of the three, okay? And then be specific, like how did it rotate? How did it reflect? Like around what was the point of reflection? Okay, and then this one, you have to copy, and then you need to do the rotations. This one is tricky, okay? It says here that you can use translation paper. Hyper technical for translation paper is also baking paper or wax paper or parchment paper. If your mom or whatever, you guys have some of that in your house, you might want to get a little, like if we were in class, I'd give you guys these little strips or little like pieces of like wax paper or tracing paper that you could actually like put on the image and then like actually do the rotation that way. So you could try that if you wanted to. This one is definitely the trickiest. I'll show you how to do this a little bit more tomorrow. Okay, but try. This might be a little bit challenging, but I really want you to try. Okay, good work.